So we have these last two problems to do to finish off 2.5. 2.5 homework is due tonight. If you need to work on it through the weekend and you get it to me before Monday, that's fine. The due date in Skyward says due tonight because technically we are starting 2.5 today, and so you're going to receive your next homework today that isn't due until Wednesday. So I try to have it's due when you get the next one. If you want to work on it over the weekend because we're not going to get through 2.5 today, that's okay. All right? So I don't want anybody going home and thinking that they can't go to sleep tonight because Ms. Bolt said they had to turn in their homework. Do I want it by the end of the weekend? Yes. Do I want it by 11:59 p.m. tonight? That's up to you. Yes, ma'am.
Wait, 2.5 is due today?
No, 2.4 is due today, but the 2.5 homework is now accessible because we're going to start it today. And I try really hard for you guys to not have like two assignments that are both on your calendar at the same time. Does that make sense? So that's all I was saying. 2.5 won't be due until next Wednesday. All right. Square roots of negative numbers continued. What are we looking at here? It says square roots of negative numbers, but these both look like what? Yeah, I've got two different polynomials. I've got a quadratic and a cubic, and we are supposed to solve these things. We can choose to use lots of different methods. They didn't specify what method we have to use, but in the end, we need x equals and x equals for the first one. And on part B, we need 3x equals. If you guys have glanced at the homework at all, it says in there on problems like this, we know that the degree of the polynomial equals the number of roots. Whatever the highest power is, that's how many answers you're going to have. Some of them could be real. Some of them could be imaginary. Some of them could be duplicates of each other. Like if I factor a polynomial and I get x minus 5 and x minus 5, I get two answers that are identical. But whatever our degree is, that's how many solutions we're going to have for our polynomials. So I want to look at this. Part A, I have an x squared, I have a quadratic. What are some of the methods we could use to solve a quadratic? Factoring. What else? Completing the square. Yes, sir. Quadratic formula. So yes, we've got three different options available to us for a quadratic. Do you guys have a preferred one that you want to start and see if it works? Factoring. Let's see if factoring works here. All right, so I'm going to make my x off to the side. I need two numbers that are going to multiply together to give me 13, but add to negative 6. Not going to work. The only things that add to 13 are what? Or sorry, multiply to 13. 13 and 1. There's no way I can take 13 and 1 and get 6. So this is unfactorable. Which means it is quadratic formula or completing the square. I think, kind of based on what I'm seeing and the questions that I was getting yesterday, I'd like to practice doing this by completing the square, just so that we get a little bit more experience with that. Are you guys okay with that? Okay. So when I'm going to solve this by completing the square, what's the first thing that I need to do? Subtract 13 from both sides. This is the only solving method where I actually don't want it equal to 0. If I'm factoring, if I'm using quadratic formula, it has to be equal to 0. But in completing the square, I don't want it to be. All right, so I have negative 13 over here, and we're going to add whatever we add to the other side. Remember, the goal on this side is that we get something squared. I want this to be a perfect square. So whatever I put on this line right here is going to complete that so that I'm like, oh, it's something times itself that would add and give me negative 6 and multiply to this. So what are two numbers that are exactly identical that when I add them together, I get negative 6? Negative 3 and negative 3. I take that negative 6x. We want to cut it in half. And so I get negative 3. We're going to take that and square it. So I'm going to put that here and over here. X squared minus 6x plus 9 factors how? Yes, x minus 3 times x minus 3, or x minus 3 squared. And that is going to be equal to 4 over here. Sorry. Yes, negative 4. My bad. I missed my negative sign there. Thank you. When we've gotten problems to this point, and I'm noticing in many, many, many questions that I'm getting, we're getting here, and because solving by completing the square isn't largely practiced in Algebra 2, a lot of people are getting here, they are re-expanding their squared binomial. So they go back to x squared minus 6x plus 9. We set it equal to 0, and we chug forward with quadratic formula. We are 2 steps away from our answer here. This is really close to our answer, and this is the power of solving by completing the square. This is why we want it in our back pocket, because it can take things that we would otherwise have to use quadratic formula for and make them shorter or a little bit easier. We worked really hard to get the left-hand side to be a perfect square, because how do we get rid of squares? Yes, sir. Square root. So we're going to take a square root of both sides. Over on the left, the squared and the square root cancel, which is awesome. I have x minus 3 equals, when we take a square root of both sides, we get how many answers? 2. We have 2 cases. We have the plus or the minus. And I'm leaving it written like this for just a moment for a reason. If this was just square root of 4, it'd be 2. This is square root of negative 4. 2i, because I have the square root of negative 1 times the square root of 4. I always want to pull that negative out as I, and then I will simplify whatever remaining radical I have. So I have plus or minus 2i. Over here I have x minus 3. To get x by itself, I still need to add 3 to both sides. So I add 3 to each side. I want to write my final answer in the form of a plus bi. So I have 3 plus or minus 2i. When you do the homework for problems like this, it will have a blank for the first number. It'll already have the plus or minus in there, because that's not a symbol you guys have easy access to on your keyboards. It'll have a blank for the coefficient on the imaginary part, and it will already have the I there. So it's already set up to accept your answer in the form of A plus or minus BI. You just need to put those coefficients in there. Okay? Do you guys have any questions for me on part A? All right. Part B, what is this? Yes, this is a sum of cubes. And so we're going to use soap here. I need the cubed root of each of these pieces. What's the cubed root of x cubed? X. And what's the cubed root of 125? 5. These will be the pieces that I use for my binomial factor, for my 2-term factor. We're going to get what here? X plus 5, same sign here. So remember, we have A and B. And then we're going to have our trinomial, our 3-term factor. What will the first term be? X squared. We take whatever A is and square it. So in this case, that gives us x squared. What about my middle term? Minus 5x. We have A times B here. Why is it minus again?
The opposite.
Opposite sign, yes. And then the last term. plus 25. There's our b squared. And that whole thing is set equal to 0. I can find the real root of this. I take x plus 5, I set it equal to 0, and I solve it for x. So one of my real roots, one of my solutions, is -5. For that quadratic factor, we talked when we were learning or reminding ourselves how to factor using SOAP, that this quadratic factor is unfactorable, it's irreducible. So when we were asked to fully factor, we could stop here. But I wasn't asked to fully factor here. I was asked to do what? To solve it. So I have to keep going. I know I can't factor it, so that means quadratic formula or solving by completing the square. You want to complete the square? All right, we can do that. So to solve by completing the square, I'm taking this piece right here and I'm setting it equal to 0. Just like we did with our other factor, x plus 5. Solving by completing the square, I'm going to take this and kick it to the other side. So I'm going to subtract 25 from both sides. We can absolutely do this one solving by completing the square, and I think it's important we get the practice. If I were just doing this one on my homework, when I got to this point right here, what do I need to do to that -5 to figure out what goes on the blank line? Divide it by 2, and then I square it. I know I'm going to end up with fractions there. I might choose to be like, you know what, I think I'd rather do quadratic formula here. We can do it solving by completing the square, and so I'm going to continue to roll through using this method. But again, if the directions just say solve and it doesn't specify which method, you go to whatever you are most comfortable with. All right, so I need to take this -5. We're going to cut it in half. So I have -5 over 2. And then I'm going to take that and I'm going to square it, which would give me what? 25 over 4. All right. So the left-hand side is going to factor. We just forced it to. We just forced it to be a perfect square trinomial. How will this factor then? X minus 5 over 2. Quantity squared. And that is going to be equal to, let's do a little bit of side work over here. I'm going to make this -100 over 4 so that I can add 25 over 4 to it. And I get what? -75 over 4. Where do I go from here? Square root both sides, which is going to result in a plus minus over there on the right. So I have x minus 5 over 2 equals plus or minus the square root of -75 over 4. When I have a fraction and a radical, how do I handle that? Yes, we're going to apply the radical to both the numerator and the denominator. So I have x minus 5 over 2 is equal to plus or minus the square root of -75 over what?
2.
Over 2. Can we simplify the square root of -75 at all?
Yeah.
Yes, let's go ahead and do that. Square root of -75. I'm going to go ahead and pull out the square root of -1 right away. What perfect square will go into 75? 25. So I have the square root of -1 times the square root of 25 times, so 25 times what gives me 75? 3. Square root of -1 is I. Square root of 25 is 5. So I have, I'm going to write this in black, x minus 5 over 2 is equal to plus or minus 5 square root of 3 over 2i. We just put our I at the back always. Almost done. What do I still need to do? Add 5 over 2 to both sides. So when I do that, I get x equals 5 over 2 plus or minus 5 square root of 3 over 2i. If I wanted to, can I turn that into a single fraction?
Yeah.
They have a common denominator, so I could do 5 plus or minus 5 radical 3i all over 2. Again, on your homework, it's split into the real part and then the coefficient on the imaginary part. So I think it's helpful to see it broken down like this. If you used quadratic formula and you did reduce it down to this, you just need to remember to distribute your division the exact same way we distribute with multiplication. Every single term in my numerator needs to be divided by my denominator. So 5 over 2 and 5 radical 3 over 2. All right. Do you guys have any questions for me on either one of those? Because that wraps up 2-4. All right. One thing that I did forget to mention the other day, and several people have come to me with very valid questions because I forgot to mention it in class. When we're trying to find that missing value, like when we're trying to complete the square and it says what value here would make this a perfect square trinomial, if we are taking a square root of something, we have to consider how many cases? 2 cases. We have to consider the plus and the minus. So if I am square rooting that last term to figure out what that middle piece should be, I have to remember that it could be positive or negative there. Let's go ahead and start 2-5. Other types of equations, so specific. My drink go right behind me. We're going to touch on several different types of equations. In all of Chapter 2 so far, we've been focused on equations and solving things, whether it's solving rationals, solving quadratics. Now we're looking at solving other. We've even gotten into complex so that we can fully solve all these different types of problems. Absolute value. What does absolute value mean? Distance from 0. And what do we know about the distance of anything? It's always positive. Distance is never negative. So if I said the distance away from 0 is 9 units, where could I be talking about on the number line if we're talking about something that is 9 units away from 0? Yeah, positive 9 or negative 9. So x plus 7, since we know the distance is equal to 9, x plus 7 itself is equal to either positive 9 or negative 9. What do I do to get x alone now? Subtract 7 from both sides. So I have x equals negative 7 plus or minus 9. Do I have 2 solutions right now?
Yes.
Technically, yes. Are they simplified?
No.
Your answers always need to be fully simplified. So plus or minus means two separate cases. I'm going to break this into its two separate cases here. One where I take -7 and I add 9, and the other where I take -7 and subtract 9. Because now I can simplify each one of those and see my two distinct answers. So far, so good? All right. So what are my two solutions here? 2 and -16. And how can I make sure that those are correct? Substitute them back in. So if I take 2 and I put it in the place of x, 2 plus 7, 9. How far is 9 from 0? 9. We're good. -16. Put that in the place of x. -16 plus 7. -9. How far is -9 from 0? 9 units, so we are good. Both of those solutions check out. Part B. I can't just jump into the plus minus thing here. The only thing that means distance in this equation is this part. We need to isolate this first before I can consider my two cases. So what do I need to do in order to isolate that absolute value? Add 8 to both sides. So I have 3 absolute value of x minus 4 equals 10. What else? Yes, multiply by 1/3 or divide by 3. Love that you said multiply by 1/3. That is actually more correct than saying dividing by 3. Absolute value of x minus 4 then equals 10 over 3 plus or minus. Do you guys remember way back first week of school when we talked about how can I drop this absolute value? If I know this is true about x, or if I know that is true about x, one of these cases is going to leave x minus 4 equals 10 over 3. It leaves it completely unchanged. The other case, the negative case, and I'm going to write this down slightly differently, but it has the exact same result. It would be negative of that equals 10 over 3. I can divide both sides by my negative here. X minus 4 equals negative 10 over 3. That's just another way to think about it or look at it. That ties it back into what we did at the beginning of the year. If you want to write down plus or minus 10 over 3, that is absolutely mathematically correct and is fine. No matter which way we went about it, whether you did it this way or whether you did it the way that was in part A, once I get to this step here, what do I need to do to finish solving? Add 4 to both sides. So I'm needing to add a whole number, 4, with 10 over 3. What do I need to do to this guy? Make it a fraction over 3. So 4 is equivalent to what over 3? 12 over 3. So I end up with one solution being 22/3. For the other one, 12 over 3 minus 10 over 3, 2/3. I want you guys to go ahead and do part C. Do part C on your own. I'm only going to give you about 2 minutes or so. What's my first step? Add 4 to both sides. So I have -2 times the absolute value of x plus 8 equals 10. And then divide both sides by -2. And so I get absolute value of x plus 8 equals what? Equals -5, because I just divided this by a negative, right? Hold up. What's wrong? Can't be true. I didn't make any mistakes here, but what did we say at the beginning about absolute value?
Always positive.
Cannot be a negative number because it's describing a distance. So what are my solutions? Is there any value of x that I could substitute in here that when I apply the operations on the left would give me a result of 6? No, this is not possible, so it is no solutions. And as a student, the number of times that I would know that in the back of my head, but as soon as you hand me an equation, I start chugging through order of operations, and we're going to find x. And I'd get an answer, and I'd get it wrong. Because I wouldn't stop to check my conditions here. What has to be true about this type of equation? Okay. Equations involving grouping. Unless you are using solving by completing the square, we want this equal to 0. If you decide to use a method of solving by completing the square on something like a quadratic, then it can be equal to something else. But for every other situation, and if I'm solving using grouping, that is a form of factoring. We have to have it equal to 0 if we are factoring. So on part A, I'm going to pull my 2 groups out here. I like it when they're side by side already. Sometimes, like we saw on a previous homework, you do have to rearrange some things to get your groups. Most of the time, they're going to be side by side for us. What can I take out of that first group, out of 9x cubed and -18x squared? I can take 9x squared out, and that leaves me with what? X minus 2. What can I take out of the second group? -4. And I still have x minus 2 remaining. All right, so I'm going to write down my factors. 9x squared minus 4 and x minus 2. We have a difference of perfect squares, absolutely. How will this difference of perfect squares factor? 3x plus 2, 3x minus 2. And then, of course, we had that x minus 2 already. Are we fully factored? Yes. So how do I find my solutions from here? Set them each equal to 0. Do you guys understand why we're setting them each equal to 0? Yes. So this is why it's so important when we are solving using a factoring method where we are going to set something equal to 0, the entire equation has to be equal to 0. For exactly the reasons that Scott stated, which is if any one of those factors simplifies to 0, that would force my entire equation to equal 0. All right, so we end up with x equals what? -2/3, +2/3, and 2. On part B, it looks like it's got groups for me already. No, why not? It's not equal to 0. We have to get it equal to 0 here so that I can use that factoring method that relies on pieces being equal to 0. So I'm going to subtract 6x squared and negative 15x from both sides. Four x to the fourth plus 10x cubed minus 6x squared minus 15x equals 0. Before I set up my two groups, I've noticed something. Greatest common factor. What is our GCF here? X. Let's get that out. So now I have 4x cubed plus 10x squared minus 6x minus 15 equals 0. Set up my groups. I still have that x out at the front. I'm going to kind of ignore him for the time being. What can I take out of my first group? 2x squared. And what would I have remaining then? 2x plus 5. What can I take out of my second group? Negative 3. And I get 2x plus 5 because I removed a negative equals 0. So x times 2x squared minus 3 times 2x plus 5. I knew at the very beginning we were going to end up with how many answers? 4. Because? Yeah. The degree of this polynomial, the highest exponent, the biggest degree, or the biggest power, is a 4. So we're going to end up with 4 final answers. Make sure you check at the end that you have all 4. Right now I only see enough to get 3. Yeah. X equals 0 here. So there's one solution. This guy over here is going to give me x equals what? Negative 5 over 2. So there's 2 solutions. In the middle, 2x squared minus 3 equals 0. You can do quadratic formula with this. I think this one is easier to solve in more like a completing the square method. I would add 3 to both sides at this point. So I've got 2x squared equals 3. Where to from here? Divide both sides by 2. And after we divide by 2, what are we going to do? Take the square root, which gives us how many answers? 2 answers from this. Because when we take the square root of both sides, we get plus or minus. So I have x equals plus or minus, excuse me, square root of 3 over 2. Rationalize. Rationalize, rationalize, rationalize. I'm actually going to bring this over here. There we go. So I have x is equal to plus or minus square root of 3 over square root of 2. When I rationalize this denominator, square root of 6 over 2. And the square root of 6 cannot simplify any further. 6 is not a product of perfect squares. All right, so final answer here. X is equal to plus or minus square root of 6 over 2. 4 solutions. So far, so good? All right. We're going to touch on one last thing. Solving equations with rational exponents. I don't think we'll get all the way through this today, but I want to get through at least one of these so that we can kind of start to see how it works. I have x to the 3/4 equals 125. So I'm going to think off to the side. If this just said x cubed equals 125, what would you do? Cube root both sides, right? All right, I'd do my cubed root here, I'd do my cubed root here, and I would find out that x is what? X is 5. I'm going to approach this very, very, very similarly, because I know that I can take something with a rational exponent, x to the 3/4. I can split this into an exponent and a root, or an exponent and a rational exponent, but a whole number and then its fractional part. Give me some ways that I can rewrite this. I'm sorry, what did you say? 4 for our index, so 4th root, yep. Yes. We could write it like this. I like it. That's probably the way I'm going to roll forward with it on this problem. Give me another way I could write this, though. X to the third, not times x to the 1/4, but all to the power of 1/4. Yes, I could write it like this also. There's still even more variations. I could write that as x to the third with the whole thing with a 4th root around it. How I proceed is kind of personal preference, and it's kind of like which path forward is going to make this easier for me. You said up here that if it was x cubed equals 125, we'd take a cubed root of both sides, right? That took my 125 and made it smaller and easier to work with. So I'm going to stick with that plan. This one right here would allow me to make use of that. I'm going to show you how. So I have the 4th root of x all to the 3rd power equals 125. I have this thing to the 3rd power, and if I want to get rid of a 3rd power, a cubed root will do that, right? Just like if it was just x by itself. So I'm going to cubed root both sides here. So my cubed root and my cubed will cancel. So now I have the 4th root of x is equal to what? Is equal to 5. How can I get rid of a 4th root? Yes, Aiden? We can put it to the power of 4 on both sides. So here, the 4th power and the 4th root will cancel out for the exact same reasons that they did up above. So I have x equals 5 to the 4th power. What is 5 to the 4th power? 625. Something I want to caution you guys about, and we're not going to do these other problems today. We'll hold off until Monday to do the rest of the ones that are up on the screen. Something I want to caution you about. When you get to the end, please make sure to check your answer. Because sometimes, like when we take a 4th root of something or a square root, we're going to end up with more than one case. We could end up with a positive or negative. I need to make sure that whatever I get as a final answer, if I put it in the place of x, it really will give me the answer that it indicated at the beginning. So if I take 625 and I put this in here for x, 625 all to the 3/4 power. Well, I'm thinking 4th root of 625 to the 3rd power. That's the only way I'm going to be able to do this without a calculator. 4th root of 625? 5. Technically, we could get positive or negative if we were the ones taking the root of both sides. But this root was part of my original problem, so we're assuming it is just the positive or just the primary. So then I would have 5 cubed. Will 5 cubed give me 125? Yes. There are certain situations where you're going to end up with a final answer and you're like, I got this. When you substitute it back in, it's supposed to be equal to something that's negative, but somewhere along the line you've taken it to the second power or to the fourth power. Can you get a negative if you have something squared? Not unless there's an I in there. That's why I'm saying always check your answer at the end. Make sure that you can get what they indicated. All right. You guys have homework due for me tonight. As long as I get it by Sunday night, 11:59 p.m., we're all good. The homework over other types of equations, 2.5, is due when? Wednesday. So one assignment, due date is tonight. Next assignment, due date is Wednesday. We are quickly rushing towards your first test. First test is not next Friday. It is the Friday after that. Do you guys have any questions for me?
Will that test just be over Unit 2?
It will be over chapters 1 and 2. It is the biggest, like it's covering more material than any other single chapter test will take.